Welcome to lesson 134 of algebraic concepts, or lesson 2134 overall. Identify quadratic functions and their graphs. Here's our objective, some vocabulary for you. So what I do want to say about a quadratic function or a quadratic equation, from trinomials, the last series of videos that I did, anything raised to the second power is called quadratic, and a quadratic has a specific shape to it. And I'm also going to talk about a vertical line test in the picture that's coming up. So the parabola is the shape that a quadratic function makes. It's a U-shaped curved, and we will see that later. So please pause through all of the vocabulary, read it, and understand the vocabulary as I use it. Okay, so the blue line is the vertical line test. If you have a graph and you drop a vertical line and it intersects in more than one spot, it is not a function. So a circle, by definition, is not a function, even though the equation of a circle, even though the formula for a circle is given by an equation. And we'll study that when we get to geometry. But in this function over here on the right, the vertical line only touches the point in the line of the graph in one spot. It doesn't matter where you do your vertical line test. You could do it here, here, there. It doesn't matter. And the same with the circle. If you drop it through the thing, it will intersect here and here. If you drop it on an edge, that's really outside of the circle, even though it only touches once on the very edge. But if you slice through the function and the myriad of points, it will hit in two spots. So that's what we mean. I know some people are going to ask the question in math class, well, what if I put the line right here and it only touches in one spot? Technically, that line is outside of the range of the function. So let's just worry about lines that intersect in more than one spot. So I wanted to show you what a vertical line test. Okay, so now this is the graph of a function, of a quadratic function or formula or equation. So it's given by y equals ax squared plus bx plus c. And you can see that there's no b in this y equals x squared. And remember, we put a 1 here. And if there's no sign, we understand it's positive. So when a is greater than 0, the u will point upwards. And that's what I wanted to show you with this picture here. And the same thing here. You put a 1 here. Our a is less than 1, is less than 0. So our graph will point downwards. -1 is less than 0. Okay, so if a equals 0, you do not have a quadratic function, because remember, ax squared plus bx plus c. If a is 0, you have a linear function. And we talked about linear functions, I think around the turn of the 2100s or close to it. So go back and watch some of those videos to go through linear functions. All right, move on. Okay, so what we want to do is be able to identify whether the graph opens upwards or downwards. And the first thing we have to do is move our things around by adding x squared to both sides and then moving the x term around. So you have y on one side, because y is your output that makes your graph. You have x squared plus 2x plus 3. There's no sign in front of the 3, so we know it's positive. So if I put a number in front of x squared is 1. So if a is greater than 0, the graph points up. So this is upwards. Okay. So now, conversely, moving 3x squared and 4x on the other side, you get the equation y equals -3x squared minus 4x minus 8. So looking at our a, -3, is less than 0, so our graph points down or downwards. And that's what we're going to be able to identify on the first problem. So now, let's look at our second question or example. Identify the vertex. The vertex is the turning point. So here's your vertex. The bright red dot right here is your vertex. Then give the minimum or maximum value. So this graph points down, so we know that A is less than 0 because it's pointing down, and this is what we mean. The U faces down. So this is a maximum value. And now we have to figure out the point. You don't see any numbers on this graph, so what you're going to do is start from 0, 0, and count 1, 2. So we went -2 in X, and how far did we go on Y? 1, 2, 3, 4, 5, 6, 7, 8. And we went up 8, so we went +8. So our point, the vertex is a point. I'm going to call it V, is -2, 8. A point needs two numbers. Even if one of those numbers is 0, 0 is still a number. So a point always needs two numbers, and a vertex is a point. Okay, so let's look at our third example. State the domain. The domain is your X, and the range is your Y. The X and Y's have all kinds of names. So let's start with our vertex. Our vertex is like 128, -28. So -28 is a minimum point. So our range goes from, so let's start with our domain. We have no restrictions here. They don't say from this point or that point. So our domain equals -infinity, and it goes all the way to +infinity. We can put whatever numbers we want to put in here. Our range goes from -28, which is the lowest point, all the way up to +infinity. Now, if this was a downward facing graph, then the vertex would be the highest point on your graph, and it would be at the top of your range. And these do not represent points. They represent your lowest and highest numbers that you could put in to make a point. And I know I've been stressing, if you watch this channel, that whenever you see a parentheses and two numbers separated by a comma, that it's a point. In this case, when we're talking about domain and range, we're not talking about a point. And maybe to change that, I will put an arrow. Let me put an arrow in. So from -28 to +infinity, and from -infinity to +infinity. These are all the numbers that you can put in to make the points. And that's that. Okay, so example 4. Find the vertex, the axis of symmetry, and the X-intercepts of the parabola. Okay, so the vertex, like I told you before, is a point. So we're going to call that V, point V. Let's see, here's 0, 0. I go 1, 2, and I go down 1, 2, 3, 4, 5. So I went up 2, -5, put it in parentheses because it's a point. Now the axis of symmetry is a line. So you need an equals when we're dealing with a line. And we're only taking the x-coordinate, and this is where the x-coordinate of your vertex is your axis of symmetry. So your axis of symmetry is the x-coordinate of your vertex. So the axis of symmetry is x equals 2. And you have to go back to remembering your linear functions. Whenever x equals something, you will get a vertical line. So x equals 2 gives me a vertical line on parabolas. And then now we have to find the x-intercepts. So the x-intercepts are, so -1, 0, for this graph, 1, 2, 3, 4, 5, and 5, 0. So if your vertex is below the x-axis, you will have 2 x-intercepts. If your vertex is on the x-axis, you will only have 1 x-intercept. And if your vertex is above the x-axis, you will have no x-intercepts. And we'll talk about that later on in later lessons. So those were our examples. That is what we are going to do in this lesson, is ask you to identify the parts in special words of parabolas. So please do the practice problems, and I will see you at the end of the video for a short recap. Okay, so the first thing we have to do when looking at these is write them in proper order. It's 3x squared plus 5x minus 4. Let's see, a is greater than 0, so it opens up. And our parabola will look something like this. At -4, it will look something like that. Okay, so writing this in proper order, y equals -2x squared plus 3. A is less than 0, so it goes down, and our graph will look something like this. -2x squared plus 3, it'll look something like that. So it'll open down. And this U shape is a parabola. And it goes on forever. We just get tired of drawing it. Okay, so problem 2. Let's find all of the things. The vertex. It's right there. I went over 1 and down -4. So my vertex is given by the point 1, -4. The axis of symmetry is the x-coordinate of the vertex. Well, x equals 1, which gives you a vertical line through the middle of the parabola. Now, what is the axis of symmetry? If we were to cut this parabola out and fold it over, if we were to fold this side over, it would give us a mirror image. Symmetry gives us a mirror image. So the axis of symmetry. Do we have a maximum or a minimum? we have a minimum. Because the parabola opens up, I know that a is greater than 0 of y equals ax squared plus bx plus c. The domain and range. The domain is from negative infinity to positive infinity because I have no constrictions. Let me not, I keep putting a comma, and I don't want you to think that this is a point. I want you to think that this is a range. So negative infinity to positive infinity, that's for the domain. And for the range, we want to talk about the lowest point it could be is -4 to positive infinity. And I keep putting the arrow. That's just a bad habit. Sorry about that, everybody. 2, got to bring the pen back, to positive infinity. And our x-intercepts are at -1, 0, and 3, 0. And we'll learn how to calculate these things in upcoming lessons. Okay, so problem 3. Same thing. I just wanted to show you a different vertex. So we went over 1 and we went down 1, 2, 3, 4. So our vertex is -1, -4. Our axis of symmetry, x equals -1. I know when you do these problems in school, a lot of people will say the axis of symmetry is just -1. But please be a little bit more precise and give me the line x equals -1, because x equals represents a line and -1 is just a number, and it doesn't really tell me anything because -1 could be anywhere. Is this a max or a min? This is a minimum. Our domain goes from -infinity to positive infinity, and then the range goes from -4 to positive infinity. I should have found a downward slope facing graph. And our x-intercepts are -3, 0, and 1, 0. So this point right here and that point right there. Okay, problem 4. For the parabola shown, identify the following. Oh, look at this. We do have a downward facing one. All right, so our vertex is 2, positive 4, is 2, 4. The axis of symmetry, x equals 2. It's a maximum. The domain goes from positive infinity. You can't go from positive infinity. You don't start at positive infinity. You start at negative infinity and goes to positive infinity. Our range goes from negative infinity all the way to +4. And then the x-intercepts are here at 0, 0, and 4, 0. So 0, 0, and 4, 0. And so that is identifying quadratic functions, quadratic formulas. Not quadratic formulas. Quadratic formulas has a special meaning. Quadratic functions and quadratic equations. That is our video for this. Thank you for watching the video. This is a series of 8 or 9 videos. If I moved a little fast on the graphing, you might need to go back and watch some of the earlier videos dealing with parts of a line or other things. So I hope to see you on the next video, and I hope you scroll around and watch some of the earlier videos on this channel.